All right, hello. Today we're going to be talking about inverse trig functions. So this is coming at you from Chapter 4, Section 7. So please grab our class notes, Chapter 4, Section 7. So remember, an inverse maps the range back to the domain, right? So if you have a function, it takes the domain to the range. The inverse of that will take the range back to the domain. And when a function is one-to-one, aka it passes the horizontal line test, right? So something like, our exponential function, right? That's going to pass my horizontal line test. So y equals e to the x, right? That's one-to-one. And when a function's one-to-one over its entire domain, then its inverse will also be a function. Do we all remember the inverse function of e to the x, right? The inverse function was natural log of x. And what do we remember about the relationship between the graphs of a function and its inverse? They're symmetric about the line y equals x. So again, my natural log function, right, looks like this. Really nice, pretty. All right. So can I use this same idea with my trig functions? As my trig functions currently stand, no, because none of my trig functions right now are one-to-one, right? Trig functions are not one-to-one over their domains, as we can see. Fail horizontal line test, fail the horizontal line test, fails the horizontal line test. By the way, I didn't actually write this. This is tangent of x, isn't the graph here. So we will therefore restrict the domain of each trig function so that it is one-to-one and still has the same range. All right, so this is going to require us to restrict the domains of each trig function to only 2 quadrants, right? So scrolling down here, we can see our unit circle. We're always going to use quadrant 1 as part of the restricted domain, right? Because that's where all of my trig functions are positive. So then the next question is, well, where are my trig functions negative? Well, it depends on which trig function. If we're looking at sine of x, if we restrict the domain to be from negative pi over 2 to positive pi over 2, then we're looking at this portion of my sine function. And the range is from negative 1 to positive 1. And so what does that correspond to in terms of our unit circle? Well, I'm looking at a domain restriction of negative pi over 2 up to positive pi over 2. So that's what I'm going to use. Quadrants 1 and quadrants 4 are what I'm going to use for sine when I restrict its domain so that it'll be one-to-one. So I can now define sine inverse. Likewise, I'm going to use that same restriction for tangent, with the exception of, with tangent, do I actually include negative pi over 2 and positive pi over 2? No, so it's almost like putting open parentheses around negative pi over 2 and positive pi over 2. They're still asymptotes. So for tan inverse, right, I'm going to be looking at having a restricted range of tan inverse. Restrict the domain of tangent, and that's going to restrict the range of tan inverse. Restrict the domain of sine, and that'll restrict the range of sine inverse. Now, cosine, however, again, from 0 to pi over 2, it is positive. But if I were to use negative pi over 2 to 0 also, that's not one-to-one. So for cosine, I want to restrict the domain of cosine to be from 0 to pi, and that's going to put me in quadrants 1 and 2 for my cosine. So from 0 to pi. So you can see it kind of color coordinated there. Therefore, the domain of each inverse trig function will be the range of the trig function. So the domain of sine inverse is going to be the range of sine, so negative 1 to positive 1. The domain of cosine inverse will be the range of cosine, so the range is negative 1 to positive 1. The domain of tangent inverse will be the range of tangent, and the range of tangent is all real numbers. So tan inverse will have a domain of all reals. But the range of each inverse trig function will be the restricted domains. So sine inverse will have the restricted range, negative pi over 2 to positive pi over 2. Cosine inverse will have the restricted range 0 to pi. Tangent inverse will have the restricted range negative pi over 2 to positive pi over 2. All right, so these are what we're using. And here's the notation. So the inverse sign, sometimes also called the arc sign of x, is denoted by a sign with a little -1, just like inverse function, right? Inverse function notation. We had f of x and we had f inverse of x. So by that little -1, we mean the inverse of sign. Or we might just write arc sign of x, right? So the inverse sign is y. And it is the unique angle, right, in the interval negative pi over 2 to positive pi over 2. So that sine of y equals x. Right, the domain of sine inverse is -1 to 1, and the range is this restricted negative pi over 2 to positive pi over 2. The inverse cosine, also sometimes called arc cosine of x, is denoted by cosine inverse of x, right, or arc cosine of x. It is also the unique angle y in the interval from 0 to pi, such that cosine of y is x. The domain of cosine inverse is -1 to 1, and its range is again 0 to pi. And inverse tangent, or arctangent, denoted by tan inverse of x, or arctangent of x, is the unique angle y in the interval from negative pi over 2 to positive pi over 2. Again, I'm thinking quad 4 and quad 1, such that tangent of y equals x. So the domain of y equals tan inverse of x is all real numbers, right? Because that's the range of tangent. And the range of tan inverse is my restricted domain from negative pi over 2 to positive pi over 2, the restricted domain of tangent. So the value of each inverse trig function must be in its range. So this paragraph seems a little bit overwhelming. Again, with pictures, here we go. Sine inverse of x equals theta means sine of theta equals x, and theta is going to be in between positive pi over 2 and negative pi over 2. So sine inverse lives somewhere over here, right? So theta or theta, right? Theta could be a positive or a negative number. Cosine inverse of x equals theta means that cosine of theta equals x, and theta lies in between 0 and pi. So I'm somewhere in these quadrants, right? So theta is here, or theta is an obtuse angle, right? So it's over here. Tan inverse of x equals theta means tangent of theta is this number x, and theta is again between negative pi over 2 and positive pi over 2. Not inclusively, strictly. So please fix that. If there was an equal side there, get rid of it, right? Strictly less than, strictly greater than, strictly greater than negative pi over 2, and strictly less than pi over 2. So again, theta is going to be either positive acute or it's going to be a negative acute theta, right? Negative going down this way. All right, so my theta is limited. My range is limited. So let's look at some examples of how we actually use these. So evaluate the following without a calculator. So sine inverse of -1/2. What you want to do is, I say this is equal to theta. I don't say it's equal to y, because to me theta is an angle, and that is what all of our inverse trig functions give you back. Your inverse trig functions hand you back an angle in radians. So sine inverse of -1/2 is theta. So what does that mean? That means first that sine of theta is 1/2. Well, right away you should be thinking, oh, I think I know what theta is. And theta has to be in either quad 1 or quad 4. Well, if sine is negative, again, sine is negative in quad 2. No, sine is negative in quad 3 or quad 4. But because of my restriction on the range, because of my restriction on what theta can be, it's got to be in quad 4. So you draw your right triangle, reference triangle. My theta here is going to be negative pi over 6. So I can say that sine inverse of -1/2 is negative pi over 6. All right, that's my reference angle and just negative. So that's kind of the nice thing about sine inverse and tan inverse, right? Your reference angle is, if it's in quad 4, it's just negative. How about B, cosine inverse of negative rad 3 over 2? What does that equal? So again, that's going to equal some angle, where cosine of that angle is equal to negative rad 3 over 2. So again, already I'm thinking 30, 60, 90 triangle, right? But it's negative, which means I'm going to be in quadrant 2, because again, cosine is negative in quads 2 or 3, but my range restriction is going to be either in quad 1 or 2, so it's in quad 2, right? And so what's my theta? My theta is 5 pi over 6. So what does this mean? This means that cosine inverse of negative rad 3 over 2 is going to equal 5 pi over 6. So it's just using all that we've already studied in practice with all of our trig identities, those trig drills I quizzed you on. All right, how about this one, part C, tan inverse of negative rad 3. What does that equal to? Well, again, that's going to equal some angle theta. So that tangent of theta is negative rad 3. So where is tangent negative? It's going to be in quad 4 based on my range restriction. So in this case, tan of theta is equal to negative rad 3 over 1. I think of that as negative rad 3 over 2 all over 1/2, right? So my sine and my cosine, so my reference angle is 60 degrees or pi over 3. So that's telling me that tan inverse of negative rad 3 is equal to negative pi over 3. And what you see written up here is exactly, really, it's my thought process. I always draw a picture. So when I'm dealing with cosine inverse, I draw a line and I go 0 to pi, so it's somewhere up here. And then I draw the right reference triangle to match my trig facts. Tan inverse, it's in either quad 1 or 4, so I draw my quad 4 and quad 1 from negative pi over 2 to positive pi over 2 and go from there. All right, a few more examples. Evaluate the following compositions without a calculator. So this is going to be a little bit more multi-step. All right, when I look at this example, sine inverse of sine of 3 pi over 4 equals what? Well, so at first, let's be careful. Remember that when you compose a function with its inverse, you should just get back the identity function, right? Trig functions are a bit trickier, and here's why. Sine of 3 pi over 4, I can draw that, but that lives in quadrant 2. Sine inverse, what is the range of sine inverse? Sine inverse, the range is in either quad 1 or quad 4. So be careful. Sine of 3 pi over 4, that is root 2 over 2, right? Positive. So what's sine inverse of positive root 2 over 2? Well, again, sine inverse is either going to be in quad 1 or quad 4 because of my restricted range. So it's quad 1. And so what's the angle? Pi over 4. So this is an important fact. Sine inverse of sine of x does not always equal x. And in fact, it will not equal x if x is not strictly in between negative pi over 2 and positive pi over 2. Right? In this case, sine inverse of sine of 3 pi over 4 is pi over 4. It's not 3 pi over 4. However, let me scroll down a little bit. If you do have x in between pi over 2 and negative pi over 2, then yeah, sine inverse of sine of x will equal x when it's in quad 1 or quad 4. Alrighty, so next one, B, cosine of cosine inverse of negative 1. Now in this case, I've got cosine inverse of negative 1 to evaluate first. So again, what is cosine inverse of anything? It's going to be some angle theta. Where's, right, theta is cosine inverse of negative 1. Well, that means cosine of theta is negative 1. Well, where's the only place cosine is equal to negative 1? That's back here at pi, right? So theta equals pi. So cosine of pi is negative 1. Hence, cosine of cosine inverse of negative 1 is just negative 1. And I see the composition of inverse functions is exactly what I would expect it to be. And that is where we will stop for this video. Next video, we will pick right back up where we left off.